Welcome to CEC lectures. I am Dr. Preeti Jagwani from Department of Computer Science, Aribet College, University of Delhi. So in this series of database management system, today we are going to begin a new topic which is about the transactions. So when we say transaction, the term itself refers to a collection of operations that form a single logical unit of work, and we will be also kind of we can say we will be also seeing this in the context of the databases and along with an example. So basically a transaction, we can say, a unit of program execution that accesses and maybe it possibly updates various data items. So basically that collection of operation which is going to access and may update various data items, when it is bundled in a single logical unit of work, that is what you called transaction. Now in order to understand this whole definition in very simple terms, let us take an example of a transfer of money from one account to another. So when a transfer of a particular amount is happening, we are considering a scenario of a bank here, and that particular bank is managing various accounts. We are taking two accounts into consideration. One, account A, from which the money is to be transferred to another account, which is the account B. So basically this is going to consist this particular transfer is going to consist of two updates. One from one, the account A from which the money is to be deducted, and another one, the account B, into which the money is to be transferred, we can say. So this whole reading the account A, taking or we can say deducting the money from that particular account, that means updating the account balance, then reading the account B, updating the account balance of the account B, and kind of we can say this whole transfer is considered as one particular transaction. So this is what I was when I was talking about in the definition, that the collection of operations that form a single logical unit of work. So if you can see this this as a complete unit, this is a transfer, this is a transaction from one particular account to this is a complete transaction, and that transaction involves transfer of money from one particular account to another. So reading of these accounts, updating of these accounts, addition of sum into one account, addition of amount into one account, subtraction of that particular amount from the another one, and then updates and so on and so forth. All these activities will be considered as one single unit of work, and that is what you called transactions. So basically when we talk about in terms of database systems, there can be various transaction, and these transactions, we can say, can be initiated by a user program which may be written in a high level data manipulation language. For example, typically we talk about standard query language SQL when we are looking for high level data manipulation language, or it could be from any programming language like C++ or Java, which is with along with the embedded database access in JDBC or ODBC. So what is transaction, how this can be initiated? This can be initiated by any user program which is either written in any high level language, which is SQL, or it could be any programming language. So when we talk about the term transaction in case of database systems, one thing which is very important here is the database system must ensure the proper execution of the transaction. Now what do I mean by the term proper execution? That is, even if there is a failure or the entire transaction executes, So even if the entire transaction, if the situation is that the entire transaction is executing completely, then it is fine. But if there is a failure in between, the database system must ensure that either the whole transaction executes or none of it is going to be executed, because various operations are involved. So for example, let's say we talk about this transfer example, and it is having, let's say, some 5 activities. So reading the balance from A, then deducting the money, and then so on and so forth. So it is not going to be the situation that 2 of the steps, or 2 of the activities in a transaction are executed and 3 are left. No, this should not be the situation, that because the database system is going to ensure, or database system must ensure, I can say, the proper execution of transaction, that is, despite failures, either the entire transaction executes or none of it does. So basically, why this is required? In order to avoid the introduction of inconsistency, or simply we can say, in order to manage the database in a consistent state. Because if 2 of the activities in a transaction unit are going to be executed and 3 are not going to be executed, this is going to result in an inconsistent state of the database. How? That we will be kind of see in an example. So in a fund transfer example, the transaction is computing the customer's total balance. It might see the checking account balance before it is debited by the funds transfer action. So that means the amount is not debited yet, and it is going to see the saving balance after it is credited. So as a result, the we can say the total system state is going to be inconsistent. So for example, let's say account A is having 3,000 rupees and account B is having 5,000 rupees. So in totality, the sum of these two accounts is 5,000. Now let's say 1,000 is being debited from A, 1,000 is being debited from A, and others, other activities are not being executed. So what will happen? Instead of 3,000, now the balance of A will show 2,000, and balance of B is already 2,000. Nothing has been added to it, because remaining activities are not being, we can say, are not actually completed. So now the earlier the sum of the two accounts was 5,000, 3,000 and 2,000, but now the sum of the two accounts is 2,000 and 2,000, which is 4,000. So that means there is there is a missing amount of rupees 1,000. So this situation is, we can say, it is actually an inconsistent state. Now the point is, when we talk about how these transactions are initiated, and that we have seen it could be any high level data manipulation language or programming language. So basically, when we want to look for a transaction in a programming language, or in a JDBC, after some JDBC or ODBC connectivity, a transaction, when you want to look for, is actually delimited by the statements, or we can say function calls, and the transaction begins or the transaction starts from the word, or from the we can say term begin transaction, and it is going to be completed with the term end transaction. So whatever operations or whatever actions are written in between this begin transaction and end transaction, the unit of that transaction consists of all the operations executed between these two terms. Now coming to what kind of properties or what characteristics a particular transaction should possess in order to maintain a database in a healthy state. Now why I am using the term healthy here, because it is not about the consistency only. There are other properties which are to be or there are the others factors or other parameters of a database's health which are to be seen. So, a transaction we can say must satisfy 4 properties. One is atomicity, another one is consistency, third one is isolation, and fourth one is durability. So, these properties are known as acid properties, and the term acid is being we can say evolved from by taking one particular or the first letter of these properties, which are atomicity, A as in, then C from consistency, I from isolation, and D from durability. So, in we can say for the sake of simplicity, these are known as acid properties. Now, we will try to see how these acid properties are being satisfied in case of transactions, and we will be taking example of that fund transfer transaction which we are considering. So, collection basically I have already told you that transaction is the collection of steps which must appear to the user as a single and an indivisible unit, and because of this being a complete individual unit which is not divisible. So, either the whole transaction should execute, or none of these steps should execute, and I have already given you an example that how this is going to introduce inconsistency in the system if some of the steps are within the transaction are executed and some are not. And here the database also ensure that if a transaction begins to execute, but because of whatever reason it fails to complete, then any changes to the database that the transaction must have made by that time must be undone, because it is not we can say it is not completed. So, taking that particular example, if the amount is being debited from account A, but not credited into account B, before kind of we can say going to the further steps after the transaction, this amount whatever is being debited from A must be we can say credited to A, because the transaction has been failed, and any changes to the database, because this transactions have been this transaction have made, then these must be we can say undone. And this requirement holds regardless of whether the transaction is failed or the operating system crashes or the computer itself stopped operating. There can be various scenarios. If we can say transaction itself is failing, maybe because of an we can say logical error, divide by 0 or something of that sort. Another reason of this transactions not being completed is the operating system is crashed, or even the computer somehow itself is stopped operating. So, in any of these situations, if your transaction is not being completed, then in that situation it must undone all these changes which are taken place as this transaction has after that transaction has started. Now, this is actually we can say a property which is all or none. All or none means we need to ensure that this requirement is met, because the database is going to be either take the whole transaction or it is not going to take any of the steps of the transaction. But we need to be very specific here that ensuring that this requirement is met is difficult. Now, why it is difficult? Because some changes to the database may still be stored only in the main memory variables of the transaction. Some may have already been written onto the database which is stored on the disk. So, all the changes which are in the main, which are done in the main memory variables or which are done on the database which is stored on the disk are to be undone. So, this is what you call we can say all or none property, and this is the first property, which is referred to as the atomicity. So, atomicity basically says that either you take the whole transaction or you do not take any of the steps of the transaction, and this particular the term atomicity here is having a reference in the sense the transaction is taken as an atomic unit. This cannot be divided further subdivided, we can say. So, either we will take the whole or we will not take it. Now, another property, we have seen the asset properties, which is atomicity, consistency, isolation and durability. Let us consider the third property, which is isolation. So, isolation, when we talk about, even if you see a single SQL statement, it involves many separate accesses to the database, and a transaction, as we have already seen, it may consist, or that's a very high possibility, that is it is going to consist of several SQL statements. So, ensure that the transactions operate properly without interference from concurrently executing database statements is referred to as isolation. So, what does it mean? So, there are, let us say, various transactions which are operating, various steps within those transactions are being carried out. But if we are talking about transaction 1 and if we are talking about, let us say, transaction 2, these are the two transactions which are happening, and even this transaction 1 and transaction 2 may consist of several SQL statements. These transactions should operate without interference from the concurrently executing database statements. That means these transactions should we can say execute in isolation from each other. They should not interfere into each other's processing. Now, coming to the third property, which is we can say is durability. So, durability says even if the system ensures the correct execution of a transactions, this may serve a little purpose if the system subsequently crashes and as a result the system forgets about the transactions. That means you have not, we can say, saved your transaction. System has ensured that the execution which is completed or execution which is done, we can say, is of a transaction is correct. It is maintaining the isolation, it is also maintaining the consistent state of the database, it is serving the atomicity also, but this is not going to be we can say justifies if the system is going into a crash and as a result the system forgets about the transaction. The system the system has not saved the transaction into the database. So, basically what are we going to say here is the transactions action must persist across the crashes also, and this property is referred to as durability. That means your system your transaction has to be durable. That means it should persist around across the crashes also. Now, when we talk about that the three properties, we have seen the durability, we have seen the isolation, and we have also seen the atomicity. Now, the situation is we have our fourth property, which is remaining. So, let us see that. So, in that, but in the case of this fund transaction, transfer, a transaction must preserve the database consistency. If a transaction is running atomically in isolation, starting from a consistent database, the database must again be consistent at the end of the transaction. What does it mean? I am repeating here the fourth property, which is the consistency. A transaction must preserve the database consistency. That is what the property is. So, this property says if a transaction is run atomically in isolation starting from a consistent database, that means the transaction when it has started, the database was in a consistent state. Now that transaction is running atomically, that means as a complete unit we have seen, which cannot be further subdivided. It is also running in isolation, that means the two transactions are not interfering with each other. Then in this situation, when the state of the database was consistent before starting the transaction, and transaction has transaction is running atomically in isolation, then after the transaction the database must be again in the consistent state at the end of the transaction. That means its consistency should not have been we can say lost during that particular transaction. So, that is what actually we can say is consistency is. And we have seen the all properties which are the acid properties, atomicity, then we have your consistency, isolation, and durability. Let us recall them in we can say in a general manner. This is what we have seen in till this point. We have seen these properties with the example of this fund transfer scenario in order to understand these properties properly. Now, what these properties, how are we going to write these properties in a general manner, that we need to see. So, the first property is atomicity. So, we can say either all the operations of the transactions are reflected properly in the database or none are. That is what the atomicity is, and we have seen it with the help of an example. Coming to the consistency, that is execution of a transaction is in isolation, that is with no other transaction executing concurrently, preserve the consistency of the database. So, even other transactions are going on concurrently, the transaction should execute in isolation. So, execution of a transaction in isolation preserves the consistency of the database. That is what the property of consistency is all about. Then isolation. So, isolation we will say even though multiple transactions may execute concurrently, the system must guarantee that for every pair of transactions. So, let us say we have two transactions T of I and T of J, and earlier we have given in the example with a different naming convention, transaction 1 and transaction 2. So, here we are taking a technical terminology T of I and T of J. It appears to T I that either T of J has finished the execution before T of I started, or Tj started the execution after Ti finished. So, that means these two transactions should be running in such a in such a situation or in such a scenario that they should not go parallel to each other, or it should appear that they are not parallel to each other. So, it appears that to Ti that either T of J has finished the execution before T of I started, or it could be other way round, that T of J started the execution after T of I finished. That means each transaction is unaware of the other transaction executing concurrently in the system. This is what our isolation property is. Then we come to the next property or the last property, which is the durability. Durability says after a transaction completes successfully, the changes it has made to the database must persist even if there are system failures. So, if a transaction is completing successfully, the changes which it has done must be kind of written permanently inside the databases. Now, here in this example we have seen the transaction concept using a simple bank application, and we have taken a very small example of transfer from one particular account to another. So, if we see it this transaction at a low level detail, this transaction accesses the data using two operations. So, one operation is a read X. Read X says transfer of data item X from the database to a variable which is called X, and also in a buffer in the main memory belonging to that particular transaction. So, buffer is belonging to that particular transaction, and the read that executed the read operation. So, basically read X is transferring a data item X from a database to a variable in the main memory and also in the buffer. The second operation which was there was write X. This write X is just opposite of read X. It transfers the value of the variable X which is stored in the main memory or buffer of the transaction to the data item X in the database. So, read means reading the X from the database, write means writing X onto the database, and a change to the data item appears only in the main memory if it has been written to the database onto the disk. But here we are assuming that in a real database system, the write operation, even if it does not necessarily result in the immediate update of the data on the disk, here we are assuming that the write operation updates the database immediately. So, basically what I am trying to say here is generally a write operation is done onto the main memory, but for the sake of simplicity and for the kind of we can say our upcoming lectures, we are going to assume that write operation updates the database immediately. And let us say we have a transaction Ti that transfer, let us say $50 from account A to account B. So, what all steps which we are talking about will be there is it has to read A, then the balance of A will be the previous balance minus 50, then the write A operation has to be there, then read B because now this changes has to be gone into the B, and then the balance of the B will be updated as plus 50 in the previous balance, and this write B has to be there. So, here the operations which are involved is read, write, and read and write, these two operations, and we are assuming that write operation is updating the database immediately. We are not kind of we can say assuming any deferred writes here. So, in this lecture we have seen what actually a transaction is, we have understood the definition, and with the help of an example we have also seen all the properties, asset properties of the transaction, and we have also seen that at a low level your transaction is actually a combination of two operations, one is read and another one is write. So, here is a list of references which is being used for the preparation of lecture. Hope you have enjoyed it. Thank you for a patient hearing.